Hi everyone, myself Dr. Lakshmi Prasad, working as a professor in CSE in Institute of Aeronautical Engineering, Hyderabad. In this video, I'm going to discuss about spanning trees solved through Prim's and then Kruskal's algorithm. So, what is a spanning tree here? So, spanning tree of the graph is a subgraph, so that contains all the vertices and is a tree without any cycles in the graph. And a graph may have many spanning trees. So, let us consider a graph. So for this graph, the obtained sum of the spanning trees obtained from the graph will be this one. So similarly, if I'm going to construct another graph like this, and the possible spanning trees will be like this. Okay. So the spanning tree of the graph is nothing but a subgraph, so that contains all the vertices, and sometimes the spanning tree is also a tree, so without any cycles in the graph. And a graph may have many spanning trees. So let us consider a graph. So the graph is going to have many spanning trees, and subtree sometimes also called as a spanning tree. So minimum spanning tree. So let us change to an example. So where we're going to connect the cities in India like Vijayawada, Hyderabad, Bangalore, Mumbai, like this. And here we're going to have the nodes and the vertices will be considered as cities, and the distance between these cities is going to be considered as an h, and the kilometers what is there in between the cities will be considered as a weight. How this is going to be constructed means, so this is the graph, and 580 should be the weight value what I assigned here, and so these are the weights in between them. Okay, so in between this is the graph obtained. From this we're going to be construct the spanning tree. So how we're going to be construct it? So we have to find the shortest distance to cover all the 4 cities. So along with this spanning tree, so the spanning tree of the given graph is the spanning tree of minimum cost of the graph matrix. So minimum cost of the graph. So a graph in which the weights are assigned to the edges. So then the graph what I'm able to call it as a weighted graph here. So how this normally from the graph we are going to construct the spanning trees, but so if the weight is going to be assigned, so the sum of the minimum weight should be the uh, sum of the weight of all edges of the spanning tree should be minimum. So then I can able to call it as a minimum weight spanning tree. Okay, and the algorithms for this spanning tree will be Prim's algorithm and then Kruskal's algorithm. So the spanning tree of the given graph with the spanning tree, so where the cost will be minimized in such a way that we're going to be done it. So the minimum weight of the graph will be this. So the minimum weight of this graph is given. So from that we are going to construct the minimum weight spanning tree. For this we are going to have 2 types of algorithms: Kruskal's algorithm and then Prim's algorithm. So what is this Kruskal's algorithm? So this Kruskal's algorithm is going to find the minimum cost spanning tree by selecting the edges one by one as follows. Okay, So the Kruskal's algorithm is going to find the minimum cost spanning tree. So by selecting the edges one by one as follows. So first one, so have to be draw all the vertices of the graph, and then you have to be select the smallest edge from the graph and add it to into the spanning tree. So initially it should be empty one, and then next step is that we have to be select the smallest edge and add it to the spanning tree, and then repeat the steps 2 and 3 until it does not form the cycle. Okay, so the Kruskal's algorithm is to find the minimum cost spanning tree. So by selecting the edges one by one as follows. So first draw all the vertices of the graph. So initially we have to construct the graph from this. So from this we have to first draw the vertices first, and then identify the smallest edge first. So okay, one, and the next smallest edge two, and next smallest edge three. So if it is going to form the cycle, leave this edge. And next smallest edge is three. So select the next smallest edge to the spanning tree, and repeat these steps, these two with 2 and 3 until it does not form the cycle. So let us consider a graph. So what is the spanning tree for this graph? So what should be the minimum weight spanning tree of the given graph here? So in this one, first what we have to do is, so first we have to be uh, create the empty vertices first. So from this one, identify what is the minimum weight first. So first minimum weight is 1. So 1 is going to be choose consider. And next, I'm going to be considering next minimum weight. So that should be 2. I'm selecting this edge. And then what should be the next minimum edge? What I'm going to select is 2 again. So this edge is going to be considered. And what should be the next minimum weight I'm going to be considered is 2 again. So this one I'm going to be considered 2, and then I'm going to consider what should be the next minimum weight. So 3 is there, so 3 I'm going to consider. And what should be the next minimum weight? 3. So 3 is going to be considered, but it is going to form the cycle, so that kind of edges is may not be selected here. So this edge is going to be from the cycle here, even though it is going to have minimum edge. So that's why I'm going to be remove this edge. And then so next minimum weight is that 4. So if I'm going to select this edge also, it is going to form the cycle again. So that's why I'm not selecting this edge also. And next one 4. So this 4 also going to be selected, but it is also going to form the cycle again. So that's why I'm going to be remove this one also. And what should be the next minimum? 5. So 5 is going to be selected, but is also going to form the cycle here. So that's why I'm not going to select this one also. And then 6. So 6 also going to form the cycle here. So that's why I'm not selecting this one. So hence this should be the uh, required spanning tree, minimum weight spanning tree that is obtained from the given graph according to the algorithm. Okay, so what is this? So first we have to be draw all the vertices of the graph, and then select the smallest edge from the graph and add it to the spanning tree, and select the next smallest edge and add it to the spanning tree. So repeat these steps until it does not form the cycle here. So like this we are going to be construct this spanning tree from the given weighted graph by using Kruskal's algorithm. So let us consider another graph here. So we are going to be constructed. So from this graph, so first of all, what I'm doing here is that I'm going to be arrange all the edges of the given graph and then weight in increasing order of weights. Okay, so from this given graph, so this should be the given graph. So from this given graph, I'm going to arrange all the edges and in increasing order of weight. Okay, so from that, so what I'm going to select, so what is the first minimum? 1, so that's why DE, and next minimum 2 is there among these two, that's why I'm going to consider DG, and next minimum is EG. So 1, 2, 3 like this. Arrange all the edges in increasing order of weights. So from this, so first I'm going to select minimum weight of the graph. So that is 1. So it is making as marking as red color here. So this is the first minimum weight what I selected from the graph. So from this, what I'm going to do, I'm going to select the next minimum edge. So that is 2 here. So that's why I'm going to mark it. So this is the edge what I selected from the graph. And the next one, I'm going to be considered 3 here. That should be EG. So EG is not going to be selected. Why? Because so it is going to form the cycle here. So that's why I'm not going to be selected this edge. So that's why I'm going to mark it as into in this case. And next weight, minimum weight is CD. So next minimum CD. So it is does not form the cycle here. So that's why I'm going to mark it as next minimum weight. And next minimum weight GH. So GH is also does not form the cycle here. So that's why I'm going to consider that edge also into the spanning tree. And next one is CF. So CF means that, so whether that one is going to be included or not. So CF also going to be included. Why? Because it is also not forming the cycle, even though it is going to have next minimum weight. And next minimum weight is BC. So from this BC, so what I'm going to say that is identify this BC also. So BC also not forming the cycle. So that's why what I'm going to say, I'm going to say that it is going to be next minimum weight, next minimum weight of this one, right? So from this, what I'm going to say, next minimum weight is BC, and then next minimum weight is BC. So it is also not forming the cycle. Next one is BE. So if I'm going to select this H, so it is going to form the cycle. So that's why it is not going to be included here, right? So it is also not going to be included. And next minimum weight is that, so BF. So BF, if I'm going to take it, so it is what it is going to also form the cycle. So that's why what will happen, it is not going to be considered. And next one is BH. So BH is also going to be considered. So it does not form, it is going to be form the cycle. So that's why I'm not including this one also. Then AH. So AH is not going to form the cycle. So that's why it is going to be included into the spanning tree. Next, DF. So this one is not going to be considered because the sum again it is going to form the cycles and all. So that's why this one and all not going to be considered, and the total cost should be thus as AH plus HG plus GD plus DE plus BC plus FC. So that means so weight 5 plus 3 plus 2 plus 1 plus 3 plus 4 plus 3. So that should be 21. So 21 is the minimum weight spanning tree of the given graph here. Then next one, Prim's algorithm. So Prim's algorithm means that, so here the Prim's algorithm is going to find the minimum cost spanning tree. So by selecting the edges one by one as follows. So the Kruskal's algorithm is different, and then the Prim's algorithm is different. So the Prim's algorithm is going to find the minimum cost spanning tree. So by selecting the edges one by one as follows here, and so all the vertices are going to be marked as not visited. Okay, initially, and then from any vertex V, so we like to choose an as a starting vertex and is going to be marked as visited. Okay, so any vertex what is going to be taken, so that should be considered as a starting vertex, and that one is going to be marked as a visited. Then the smallest edge weight, so which connects the one vertex inside the cluster with the other vertex outside the cluster, is going to be chosen, and then it should be added to the minimum spanning tree. Okay, so the smallest edge what is there, so that one is going to be considered from the vertex in the cluster with the vertex here outside the cluster, and which is going to be chosen one, then that one is going to be added into the spanning tree. Then this process is going to be repeated until the spanning tree is formed. So the Prim's algorithm is entirely different one. So this one also going to be used to find the minimum cost spanning tree. So by selecting all the edges one by one as follows. So first of all, we have to be select all the vertices should be marked as not visited initially. So for that, so from that vertex, the vertex is going to be chosen and then it is going to be marked as visited one. So the smallest edge weight, so which connect the one vertex inside the cluster, the under vertex outside is chosen and is going to be added. So this process is going to be repeated until the spanning tree is going to be formed here. So let us consider this is the given graph. So previous thing. So from this one, what I'm going to initialize the array. So initially I'm going to be marked as not visited in this case. So all the edges are going to be considered in this one. So initially are not going to be marked. So very first thing is that, so I'm going to be start from D here. So the D, so dt I'm going to be considered in this one. So initially I'm going to mark it as 0, and from this I'm going to identify, so what are the edges that are connected from D, so that is C, and then D to E, and then D to G, and D to F. So what is the value of D2C? That should be 3, and D2E is 25, and D2F is 18, and D2G is 2. So from this what I am going to consider is that, so I am going to be consider what should be the minimum one. So what is going to be minimum? So 3 is going to be, 2 is going to be selected. So I am going to be selected this one. So from G, again I have to identify what is the minimum one. So G to E, so again from G, what I'm going to consider. So G to E, that should be 7 is going to be there, and G to H is 3. So G to E, so this one is considered, and G to H, these two are going to be added. So among this one, so what should be the next minimum? H, G to H. So that one is going to be CD. So CD is also there. So CD is going to be considered here. And from this, so next one what I'm going to consider is that from C I have to again identify this. From C I'm going to have C to F and C to B, so these two will be added here. So from these two I'm going to consider the next minimum weight. Okay, so from this again what I'm going to consider, next minimum is going to be it constraint. So C to F is selected. From F I'm going to identify what should be the next minimum weight. From F to B, so from F to A and F to B is 4 and F to E. So this two will be added here, and from this what I'm going to do, I'm going to add those two also. And from this one, so what should be the next minimum? F to E is considered, so I'm going to consider check whether the cycle is formed or not, and then from again I have to consider what should be the next minimum. So from F to E is there, so this one is going to be selected, so that is the minimum, right? So that one can consider. From F to E again I'm going to consider what should be the next minimum here, so that is G to H I'm going to be considered. So G to H is 3, so 3 is going to be considered here. From this next minimum is 4, H to A, so H to A is going to be considered. And from this remaining all the edges are going to be form the cycle. So next one is B to T, so B to T is going to be there, so T is 4, so 4 is going to be considered. So then it should be the resultant binary tree. Okay, so here I'm going to have this should be the resultant binary spanning tree from the given graph. So initially these steps will be repeated again. So initially we are going to have all the edges, it should be marked as empty first, and then what I'm going to do, initially I have to select one the starting one. From this I'm going to be identify the vertices that are then connected to the other vertices. From this minimum is going to be identified. From G again I have to identify what are the minimum vertices, so that one is going to be selected, and from this I'm going to identify what is the next minimum. Then up from this what is should be the next minimum, G is going to be identified. From G again I'm going to map the what is the next minimum, H. F is going to consider from G to H, then from H to A, and from this I'm going to consider this is the resultant final graph here. So this should be the resultant minimum spanning tree from the given graph. So from this given graph what I'm going to consider, so this minimum weight is going to be calculated. So the minimum weight of this one is also same, so 4 plus 3 plus 2 plus 3 plus 4 plus 3 plus 2, so that should be 21. So 21 should be the minimum spanning weight spanning tree from the given graph. So let us consider another graph. So how we're going to be construct this minimum spanning tree by using Kruskal algorithm. So consider a graph here. So this is the initial graph what I'm going to have. Okay. So from this, so first of all, we have to identify what should be the minimum first. So D to E I'm going to be selected, and then from one again I'm going to select what is the next minimum, 2. So 2 is going to be selected. So from 2 again I'm going to be select what is the next minimum, so that should be 3 is there, and from here it should be 2 is there. So and finally I'm going to have next minimum weight, that should be 2. So like this I'm going to be select this. So among this one, so first A to E, so A to E is going to be considered, that should be the step 1, and from next minimum is going to be there from D to B and D to F, so this two is going to be considered, and from E what should be next minimum, E to C and E to D is going to be considered. So like this we are going to be construct this span from the given graph.
Like, share and subscribe. Hit the bell icon for more updates.